like a look at the logs in table storage that note everything you type there. So Node.js, Ruby, and Python in Windows Azure, a look at what's possible. Isn't it a whimsical title? What I'm going to show you is some code that I've written and have yet to publish. I've published a bunch of sample apps that run in Windows Azure and run on these things that you can take a look at. But I've yet to package up and ship the code for the framework for running these things, which I plan to do as soon as the combination of lawyers and project people and whatever tell me exactly where to put it and with what license, and then we'll go from there. So I'm going to show you how to do all this stuff. I'm going to show you some examples of it. We're going to talk a little bit about why you might want to do it. But I want to do let me poll you guys a little bit first and just ask, how many people actually write code in one of these three languages sort of as a regular thing? Okay, good. That's kind of, I expected a lot of the audience to be like that. Okay, now let me do how many are doing server-side JavaScript like with Node.js? A couple people. How many people are writing Ruby? A lot more people. How many are doing Python? Okay, wow, that's a very healthy mix, which is good because I really want to talk about all three, and I'm sort of afraid that actually Node is the underrepresented crowd here, which is too bad because you guys should pay attention to Node. I think it's a very cool thing. JavaScript is an appealing language for a lot of reasons, and Node makes it really practical thing to do on the server. Okay, so I am Steve Marks. My title at Microsoft is Tactical Strategist. Okay, good. I always worry it's not obvious that it's a joke, and then
we have a competition for coolest title.
a competition for coolest title. What's the competing? Do you have a good one? No. Okay. Well, think of one, and let's do it. My blog is at blog.smarks.com. That's actually also one of the apps we're going to talk about, and I'm on Twitter at Smarks. That's a likeness of me that I drew. Here's the agenda. It's quite simple. We're going to talk about the what, which is really about this code that I've built, what it does, how it works on Windows Azure, what you're going to get, because you can go get this stuff and use this. We're going to talk about why. This may be a little bit backwards to talk about the what first, but then we're going to talk about the why, which is, why did I build this? Why do I think this is important? Why do I think you should care about it? And then we're going to talk about how, which is really where you guys are going to guide me. This room is not too big that I think you guys can sort of yell things out and sort of tell me where you want to spend the time, because I've got a lot of sample code that we could look at, a lot of things that we could do. And it's going to be up to you which things you guys think are the most interesting. And we'll kind of play it by ear there. And then I expect to leave, depending on how that goes, I expect to leave some time for questions and answers at the end. Okay, so what is it? I couldn't come up with a name, so I called it the Smarks role. Smarks being me, Steve Marks. It's a web role that I've built that has support in it for running Python code and Ruby code and Node code. Node code, by the way, is really fun to say. And the way that it's built is it's a pre-built package, so it's something that you could grab, go deploy, and then you separately kind of sideload the actual applications that you're running. And so what's running there is sort of a shell that's kind of waiting to be filled with your actual application code. So you don't actually even need the Windows Azure SDK. You don't need any of our tools. You don't need Visual Studio. This is coming from a Microsoft guy on the Windows Azure team. This is sort of the least Microsoft stuff you'll see. But it is all running on Windows Azure, and that's really what I care about. It is coming very soon, as in it might have been this morning if we'd just gotten the license sort of settled out, but probably to CodePlex, but maybe to Code Gallery, maybe somewhere else. But I'm going to ship all the code for everything that you see, both the framework and the samples for all this stuff. And it is sample quality. So I just want to, before someone goes out in production with a website on this, I have a slide later on about kind of future stuff and what needs to be done on this. And we can talk about it there, but this hasn't been battle tested, and I'm not ready to kind of back it up with anything more than saying it's a sample. So I got lots of apps that you guys can, those of you with laptops pulled out or whatever, can feel free to play with these. We've been playing with chat.smarks.com before the talk. We were kind of messing around on there. That's the most interactive of them. But my blog at blog.smarks.com is written in Ruby, and it's using Windows Azure tables to store the blog entries. Does the meta weblog API and stuff. And this morning I shipped the source code for that on GitHub. blobedit.cloudapp.net we're going to play with. That's written in Python, and that's sort of like an in-browser code editor. Sandra.cloudapp.net is it's short for Cassandra. This is Python running in a front-end web role, and then Cassandra running as a back-end storage system. Which means that's actually Java, because Cassandra is built on Java, and there's some C# code that kind of holds it together and informs the Python about the different Cassandra nodes. And then there's this smartcms.cloudapp.net, which is something I was messing around with to see if I could help our documentation team on something. It's a CMS, little mini CMS engine written in Ruby that calls out to Python to do syntax highlighting. So the point of these examples, one is they're going to be the vehicle by which we can kind of look at some of these things. So we'll look at some of those in a little more detail, and then you can see how they're actually built and how they work. But I also want to give you a feel for the fact that you can actually build like real apps. These are not super high-scale, impressive apps, but that's just because of my lack of imagination, not because of anything about the platform. The platform really supports really using these technologies in production, building real-world things with them and doing it. And one of my big goals out of this talk is not just to share some stuff with you that I think is cool and I think you might like. That's one of the goals. But I also want to convince you that this is a reasonable thing to do, that Windows Azure supports this sort of thing, and that this is something you should feel comfortable doing with the platform. Let's do some sort of code. What can we do? So I've got this app. I've got a sort of dummy app here that's right now saying hello from Python. Let me zoom that in. And let me show you how that's happening. So this is what the Smarks role looks like when you've deployed it. It gets configured to point to a couple different possible locations, but one of those is blob storage. And so it's pointing to blob storage. This is a tool called Cloud Explorer by Clumsy Leaf. It's a nice free tool for interacting with blob storage. And you'll see here, I've got a couple files. Wow, that was way more zoomed in than I meant. Called app.py and pip file. How many people know what pip is? All the Python guys should maybe raise their hands, but not everybody. Or easy install. Have you used easy install if you're doing Python, especially on Windows? It's kind of handy. But pip is kind of a package manager thing for Python. So if you do pip install pigments, then it installs the pigments library for Python. And so I've got this little app, and that's what you're actually seeing in the browser is the result of that stuff. And this is that code. It's using Tornado. How many people have heard of Tornado? It's a Python web, yeah, a lot of you have. It's a Python web server, for those that don't know, that was originally developed by FriendFeed, and then Facebook sort of open sourced it at some point. And it's sort of built for high concurrency and whatever. So it's what I've mostly been using for my Python examples. So this is it. This is the hello from Python. I've got some other stuff in here, like a Ruby hello world that says hello from Ruby. And a corresponding gem file that makes sure Sinatra is there, because Sinatra is the framework that I'm using. How many people have used Sinatra? I love Sinatra. There's a .NET, I think it's called Nancy. I believe it's called Nancy, which is basically a .NET version of the Sinatra thing. Not quite as pretty syntax because it's written in C# instead of in Ruby, so it's a little harder to do that. It's a little harder to get this pretty of a line, but it's kind of cool. So for those of you who are doing mostly .NET development but find this appealing, check that project out. So I've got this. The question, really the reason I'm pulling this up is I want to show you how this stuff all gets deployed. And so what I'm going to do here is I'm going to grab the Ruby file and the gem file that just expresses the dependencies and delete this stuff and paste these in. And I don't know, within about 5 seconds, I think. I set the interval for 5 seconds. Within about 5 seconds, it should pick up the changed code. Oh, it's already been more than 5 seconds. I'm a liar. It should run through, it should do a gem install, which is the Ruby version of installing the necessary libraries, and then it should pop up here and say hello from Ruby, which it's clearly not. I don't know if I'm editing the right, if I'm configured to look at this. That is the worst demo I've ever seen. I'm mystified. Wait a second. Okay, what did I'm so mystified that I want to debug it right now. How exciting is that going to be? So, whoa. There we go. So how many people have used remote desktop to go debug something in Windows Azure? All right, good. For those of you who haven't, you're about to, unless it's sort of, okay, all right, fine. I just had to threaten it. That was apparently the, it heard me. Okay, wait, let's do something cool. Because that didn't have the whiz bang that I really wanted out of this. Let's show this other app, which is pointing there. You can use this too. You can edit your blobs with this. All right, let's see if this is more dramatic, because I really thought 5 seconds was more of the time. Oh, great. Actually, that one I almost expect. So one of the things that I will call out in the future work sort of thing is that one of the things that Windows Azure does really nicely for you is it manages updating your app by doing this sort of rolling update where it never takes down everything at once. Meanwhile, I have code that every 5 seconds just copies some new stuff down and restarts processes, which means everything goes down at the same time. So you can always catch it. There are a couple seconds, no matter what edit I do here, there's a couple seconds where this whole thing is just showing a 502 error. And so, anyway, so what I did there was a different way of editing a blob. So if I go back to blob storage and we try to open up this file, we will see it says hello from Ruby again with oddly a missing last line. But this does the same thing, so I guess that line is there. Anyway, so as that super impressive demo showed you, this whole thing is sort of built around the idea of we're going to deploy this sort of shell. It's going to be constantly syncing my app code, which means as I make changes or as I make deployments, it's this sort of instantaneous thing. I just wanted to reinforce that it's sample quality. So let's talk about really why are we doing this? Why are we bothering to look at this at all? And basically this comes down to really one central thing, which is that I think platform as a service is awesome, and I refuse to be convinced otherwise. I think it's really the way to go. I think that you're going to see everybody's going that direction. That's what we're going to do. I think it's hard to do platform as a service and still be still work with a bunch of different languages and a bunch of different frameworks. It's possible to build really great platforms as a service, is that what you say? For specific languages or specific frameworks, and I think we're going to see lots of them get built. I'm betting that something that people are going to need is the general purpose platform as a service, which is a phrase we've used for probably the past year, I think, to describe Windows Azure, which is we really think, look, if it runs on Windows, then it runs on Windows Azure, and that's a lot of different stuff. But we still get some features of being a platform as a service, like automating things like OS updates or servicing the application, automatic sort of scale out and scale back in, or dynamic scale sort of at your choice. Still dedicated VMs with sort of real hardware that you know what the specs are for, and you get sort of guarantees about performance and isolation. You get the storage that's in Windows Azure, so we have blobs and tables, which are really the kind of NoSQL options, if you will. We have SQL Azure, which is the SQL option, the relational database. We've got data centers around the globe, currently 6 full data centers that you can run your application in. And now with the Traffic Manager, which was just announced this morning, you'll actually be able to route traffic intelligently to your application sort of across all those data centers if you want. We also have a CDN, which you can use for your blobs or for your whole app. And there are 24 locations right now, which guarantees that this video is dated. If you were watching this video and it's been more than like a month since the talk, it's probably more now. They're literally popping up all the time. That stuff is really all great. And so this slide is both, I want to sell you a little bit on Windows Azure and why I care about Windows Azure and think it's important. But I also want to make the point that I want to get all that stuff, and I want to get it with my programming language or my framework and my tools. And I don't want to have to sort of compromise on those things. And I think that Windows Azure has the opportunity to really be that platform where you can bring all your existing skills and all your tools and all your languages, and not just the Microsoft-centric ones, and still get a good experience on a really strong platform with a strong SLA behind it, et cetera. So that's kind of the why. Here's some code that's kind of cool. This is running, I think, at smarkcms.cloudapp.net right now. This is the whole code as we scroll down here. I think the thing that I really wanted to point out here is that this is using Pigmentize, which is actually Python code, and then the rest is Ruby. So it's sort of formatting some things with Ruby, and then it's doing some syntax highlighting using Python. And the reason why I think this is a particularly cool example is because it's showing the value of having this platform that runs multiple different languages. The other one, that Cassandra sample that I talked about, is also another one where it's showing that value, where you can have Python in the front, and then you can have Java running something in the back end. And we support all those different kinds of workloads and those different kinds of apps. It's not just web apps that are sort of standalone, and it's not just apps that are written in one language. So this is yet another example of kind of multiple languages coming together in harmony. Okay, so let's talk a little bit more about the how, because I want to make sure I show you guys what the platform is capable of and how that enables things like this. So I've started to push back on the word interoperability. We talk about that a lot at Microsoft on a variety of projects, and a lot about Windows Azure. And sometimes we misuse it. And I think this is one of those cases where I might have misused it, and I might have put something on the slide about interop. And that's not really what it's about. It's really, I'm taking the inter out of it. And it's really about operability and the idea that we have Windows, which is an operating system that can run any number of different languages, any number of different frameworks, any number of different tools. And the philosophy in Windows Azure is if it works in Windows, it should work in Windows Azure. Most of the time, that's sort of trivially true because we're running Windows inside virtual machines. And so if it runs on Windows, it will run there. But I think there's also a philosophical idea there, which is we're about sort of being the general purpose platform, and we're not about pushing only one kind of language or one set of tools. And you're going to see us doing a better job, I think. We started off in a sort of .NET-centric place, and so I think you're going to see us growing and maturing here as we go. But that's the basic philosophy. And some things that are somewhat recent in Windows Azure, so if you haven't been watching carefully, you may have actually missed. But all these were kind of announced at PDC and shipped sort of right after that at the end of last year. We now have elevated privileges, and that means you can run as admin, so you can do things like run installers and configure things, change registry keys, whatever you need to do. So that kind of sort of opens up sort of how you can prep the machine and get it ready. Startup tasks, which run before your role actually starts, they're a good place to do that sort of thing. They're sort of separate from the rest of your code. You can run those elevated, but then run your actual application not elevated. I think that's a good thing. We've got full IIS. The only reason we call this out is because we used to not have full IIS. We used to have hosted web core, which is a significant portion of the IIS stack, but has a few limitations, like you can only run one site and one app pool when you're doing that. Now we've got full-blown IIS, which means if you add startup tasks and elevated privileges, you can do things like install custom modules, do things like that, and sort of get a lot out of that. So these are all features that have recently come into Windows Azure, and I think they are perfect for doing the sort of work that I've been doing with these other programming languages, which is I need a way to get that machine set up and get everything ready to run those things, get the frameworks installed, et cetera. And I need some of these capabilities to do that. Notice that on the last slide, I did not mention the third bullet here, which is VM role. So we're going to talk about it now, but I'm going to tell you why I didn't mention it on the previous slide. So this is a little bit of background if you're not a Windows Azure guru already, but we have 3 kinds of roles in Windows Azure. We have a web role, a worker role, and a VM role. The VM role is quite new. In fact, it's in beta right now. Web role is basically for hosting websites. We start IIS and point it at the directory where all the bits are that you uploaded. That's basically the idea. It can do all sorts of other things, but that's what it's commonly used for, is start up IIS and point it at a directory. That might be an ASP.NET application of some sort. It might be PHP. It could be some other things. If you've set up fast CGI and whatever, you could run some other things. A worker role is for pretty much everything else. So a worker role, the deal is you give us a .NET assembly, so DLL with a main function. It's actually called run. There's an on start and then a run. I wish we'd call one of them main because it would have made this analogy a little easier. But that's basically what it is. So we will load up that assembly. We will call the start. We'll call on start, then we'll call run. And you're expected to never come back from run. You enter some infinite loop of some sort at that point, doing whatever it is that the work is that you do. So worker roles commonly used for doing sort of back-end processing sort of things, asynchronous workloads very often. But they're also useful for things like running other web servers. Like if you're going to run Apache in Windows Azure, you're probably going to use a worker role to do it because you don't actually want IIS and you don't want it bound to those ports and whatever. So you'll go to a worker role. You'll still declare you want an HTTP endpoint, so you'll get traffic on port 80, but you'll run your own web server. Okay, and finally there's the VM role. And I put it finally for a number of reasons, right? I view the VM role as a last resort. That's a slightly controversial thing to say, even among the Windows Azure team. But this comes back to my belief that platform as a service is awesome. VM role still gives you a lot of the platform as a service things, but you lose one. You lose the automated OS servicing. And to update any of your code, you're sort of deploying a whole new VHD, which is kind of a pain. So you got to go build that up, and you have to ship it up to the cloud. Now, we're doing lots of things that are going to make this a smoother experience and a nicer experience and a faster experience. And so I may have to sort of back off of my last resort comments about VM role as it comes into its own and sort of fills that. But I find that most of the things I might want to do in a VM role I can do with startup tasks and elevated privileges. And so I've been on sort of this kick of not using the VM role when I don't have to. And that's the case for all the code that I show here, is it's running, this SMARCS role thing is not running in a VM role, so it's not some custom VHD. It's just some startup tasks that install a bunch of things. All right, so here's the big picture. Yes, I drew that myself. I know you think that I went to one of these fancy design firms and said, I need a beautiful diagram here. That the pirate there, that's R, the application request routing in IIS. The rest is sort of, so basically, I've got traffic coming in on port 80 to a load balancer. That happens automatically in Windows Azure. If you have traffic coming in, it always goes through a load balancer. We set that up, and that's just sort of a part of the platform. It's sending that on to any number of web roles. You get to pick this. This is how you scale. And each one of those web roles is running that SMARCS role code. And that SMARCS role code is IIS with application request routing acting as a reverse proxy. Does everyone know that you do this with actually with all three, with Ruby, Python, and Node? You almost always run a reverse proxy. How many people already knew that? They think I'm just slow for not knowing it already. Okay, good. There are enough people who don't know that I don't feel bad for having only recently learned this. So there's a problem actually with a problem is gonna now it's gonna sound like I'm picking on these languages. All these things run sort of single-threaded. It depends actually on the framework that you use, but particularly actually Node is really designed around this sort of single-thread, everything's async kind of model, as opposed to spawning a bunch of threads. Tornado actually works in a similar fashion on Python, and Ruby sort of as a whole pretty much works this way. And it ends up being the case that they really can't take advantage of multiple processors in the same server, which means you almost always end up running a few of them. Okay? There are other reasons people do this, like stability. There are questions about, well, what if one of these crashes? It'd be nice to have a couple other threads going. But so basically, everybody does some tuning, and they decide how many processes should I run. Usually depends on how many CPU cores you have on the server that you use. But I didn't think it was really a credible story for this stuff unless we modeled that. Now, if you're running on like small instances in Windows Azure and there's only one CPU core, it might actually be reasonable to just run one of these processes. But I wanted to make sure we could do that scale. So that's the reason for having this pirate here, is that he's acting as the reverse proxy in front of these and sort of farming out to some number. I hard-coded that it's up to 8, but you could just change it. Up to 8 processes that run in there that are running Ruby or Python, or I put Ruby on the slide, but it's anything. And then we've got some code which, as I mentioned, might come from a variety of sources, but somehow, just for now, somehow some code gets onto the box, and these interpreters are running on top of that in multiple processes behind this reverse proxy, which is IIS with application request routing, which is then behind a load balancer so that your many VMs are also kind of balanced out. Okay. I just wanted to see how long I could keep this pirate up on the... Sure. Was it instantly recognizable as a pirate? Did you at least know it was a pirate before I said that? Okay, good. I'm proud of myself then. I spent more time on that than the rest of the deck. Okay, so it's not true. So more about those components. I said almost all of this already. I think really the two last bullets are an interesting thing, because if you were going to go take this code, which I hope some of you are here because you think you might actually go do something like this in production. So I hope that you take my code as a starting point. And if you're going to do this, the places where you may plug in some other sort of stuff, if you don't like what I did with Ruby and Node and Python and you want to do something else, or you don't like what I did with syncing from blob storage and you want to get that code from somewhere else, these last two are sort of an extensibility point where you can have different kinds of things that can run code and different kinds of providers of that code. So those are both kind of pluggable places. And by the way, I didn't have to do the last bullet. In fact, I didn't have to do the last 2 bullets to get all the stuff that I wanted. I could have had just a totally different kind of role for Ruby versus for Python versus for Node. And that would have gotten rid of the need to kind of understand multiple runners and figure out based on the file name what interpreter I should invoke. And I didn't have to do the last one because I could have just packaged the bits with the app, which is what you typically do in Windows Azure. Then you wouldn't have seen the 502 that I showed there because you'd never have a time when the process was down. Now you'd be doing the rolling upgrade that you're supposed to do in Windows Azure. Oops, I think I skipped one. All right. So a little more about the reverse proxy, because now we're getting into like, this is the part of the talk where we're descending into code. For the most part, the rest of what I want to do is just point out some things in code for you. As I said, I'm shipping all this code, so you can go look at it to your heart's content later. I'm going to judge based on the faces you make, largely, how interesting different parts of this are, and I'm happy to go into any depth. And when we get to sort of Q&A, we can also back up and kind of look at these things deeper if you want. But I wanted to show you how this reverse proxy gets set up. So this is sort of my argument against VM role, is this sort of startup task. It's like, yes, I could go get a VM role and I can install application request routing and get that set up. But I could just launch the MSIs as a startup task and install it, and it works fine. And to me, that's easier, because I'm the kind of guy who would rather script that and get it done than have to go set up a VM by hand. So what this is doing is installing the web farm framework and application request routing itself. If you're going to do this sort of thing, always do this. Put a /qn, which says like really, really be quiet and don't pop up any UI and ask me questions. Because if one of these dialogues pops up as you're starting up a role instance in Windows Azure, you're not there to click on it. You don't want that to happen. I think it's also a good idea to do this, because what I was about to do, what I was threatening when my code didn't work as fast as I wanted, was threatening to go RDP and look at the machine and see what was going on. And there, having log files lying around of all the installs you did helps you to figure out why this thing is missing or something like that. Okay, and then this is a bunch of code that's basically calling app command to set up a bunch of stuff. I'm going to show you on the next slide what this all looks like after it's set up. But this is basically configuring application request routing. This part is kind of fun. Application request routing has a limitation, that's my friendly way of saying it, where each of the, it's sort of typically used as a proxy in front of a big farm of machines. And so what you put in is a bunch of different server names, and then you say what port on all those you want to use. If you're using it to all point at localhost but different ports, you actually need different machine names. It doesn't have a way, the unique key is the server name. And so this code is deleting the host file and rewriting it with a bunch of things like localhost 0, localhost 1, localhost 2, localhost 3 that all just point to 127.0.0.1. So if you go grab this code and run it on your machine, it will delete your host file. Yeah. Maybe it's good that they didn't let me ship it quite yet. I can put something in here to try to make that not happen. So this is doing, then the rest of this is my batch file foo. Set/A, how many people knew you could do set/A and do math in a batch file? Now I feel, okay, all right, fine, one guy. Take it away from me. I felt really good. So anyway, so the rest of this is basically just setting up, well, it's easier to see it here. It's doing this. So the rest of that code was just doing, just like we're putting in the host file, all these localhost 0, localhost 1. We're ending up with a bunch of servers. We've created a farm called local farm, and it just is bouncing to 8 of these different processes on the same box. Well, 8 different ports, right? We haven't gotten to the part where we've actually started all these processes up. But it's basically just pointing to these 8 different ports. I've turned off the cache because I found it confusing. If you're doing the right thing with your cache control headers, you actually like this cache. This cache is really helpful. IIS is going to offload a bunch of the work for you. I wasn't doing the right thing with my cache headers, and so when I was changing code, then I'd see some old thing, and it would lead to demos like the one I showed earlier. So every 2 seconds, I'm just getting the home page of whatever's there and to decide if it's up or not. That way, if some process stops actually working, I'll stop routing traffic to it. That's kind of handy. That's just a feature of application request routing. Here I'm saying to do round robin. Okay, and then there's this. This is the web.config. That's actually all in the directory IIS is hosting from. There's just this one file. It's webconfig. And all it says is rewrite every single URL to point to that farm. So it says take whatever comes in, send it to application request routing to do its reverse proxy thing. And the real work is being done on port 9000, 9001, 9002 through 9007, where my actual Ruby processes or Python processes are. Or node processes. I guess if I'm going to say 2 of them, I should say the third. All right. So how do we get Ruby on these boxes? Ruby was one of the more popular of the languages. So I had anticipated that this would be number 1 in terms of interest. So I put this one first. But we're actually going to look at the other ones too, but they're very similar. This one's the most complex, I think. This is the startup task. It basically does it does this get local resource. I don't think I put a slide in that shows that, but I can show you what that PowerShell script is. It basically just calls the Windows Azure API to find out where the local storage is for this thing. So I've just created local storage directories for Ruby, etc. So it figures out where Ruby is. It unzips Ruby to that location. It unzips devkit. How many people do Ruby on Windows and use devkit? Very few. Devkit is cool. It's basically it's a min-GW environment for compiling things on Windows that need make files and things like that. So it makes a bunch of gems that you want to install with Ruby basically compile better on Windows. So then this is a little GUI to just set up that devkit thing so that later when I do stuff like this. Actually, this one. it's actually building event machine from scratch. This is a bunch of, if you're not a Ruby guy, then this is sort of irrelevant. But this is a question that I think it's hard to figure out exactly how to do this well, and this has nothing to do with Windows Azure. This has to do with Windows. If you try to get an event machine set up, which is good for required for Thin, which is a very nice application server, I guess, for Ruby apps. It's tough to get it going at the moment on Windows, so you got to go build it from the current source. And so this actually uses Git to pull down the current version, builds it, compiles it at startup time, and then installs a couple other gems, and we're good to go. Just make faces if this is kind of too much. This is the actual C# code. This is more config than anything, but each one of these runners has this format. I made a little interface for it, but basically, it knows what kind of file to look for. So if you have an app.rb, this thing runs Ruby, right? That's all that first thing is doing. The second one says run bundle install as a way to get dependencies. So if you have a gem file there, then this will pull down the gems that you need. And this one says, here's how you run it. You just do ruby app.rb. I put the port on the command line, so it knows where to put it, but that gets appended later. Okay, now we can go faster through these because these next two actually look pretty similar. So Python, it's a little bit different. Instead of unzipping, I couldn't find a good, there is a portable Python. I wasn't sure how up to date that is or if it closely follows the main Python distribution, but everybody seems to use the MSI installer to do Windows installations of Python, and so that's what I did. So I just run the installer here. I got a little goo here that prevents it from installing on my machine where I already have it installed. This gets setup tools. Remember when I asked for a show of hands on easy install? I'm using easy install to install pip, which is really a replacement for easy install. And then from then on, this app actually uses pip. So that's all that's doing. This looks very similar. Look, there's an app.py. We're doing pip install -r pip file instead of that bundle install. And then we're just calling Python app.py instead of Ruby app.rb. Okay, bored yet? Here's one more. Node.js. This one is the spookiest. I should probably pause here and say, like, Node on Windows is getting better. That's what I was going to say. Okay, good. All right, so I don't have to say as much because I've been told from the audience that Node on Windows is getting a lot better. It actually already has gotten a lot better from the last time I looked at this. I started running chat.smarks.com, which is running on Node.js in December. And when I did then, I ended up compiling from source, and it was sort of a pain. Now you just you search for Windows binaries Node, and you come up with some binaries that actually work quite well. They're based on Cygwin. Then they run on Windows. All right. The Node package manager, I found I had to get the latest one from Git. Notice I even put a comment that says scary in it. That's how scared I was of this. That's what this is doing. It's actually it's using Git to pull down the very latest Node package manager, which the last time I checked was 1.0 RC5. So I don't know if that's good or bad. I don't know if that means we're really close to 1, or wow, we already had 5 release candidates means who knows how many there'll be. Is it released?
No, it's going to be pretty soon.
Okay, but it is very close. Okay, all right. You guys are making me feel a lot better about this. So all this scariness hopefully goes away very soon because it gets less scary. So there's a little bit of scariness here that is, I'm using NPM as the Node package manager, which is the equivalent, the moral equivalent of bundle or pip. At least the way I'm using it, it's for the same sort of things you use bundle in Ruby to install the gems, or pip in Python to install those packages. You use NPM to do that in Node.js. And all this is just to get the latest bleeding edge NPM onto the machine, which I found I kind of needed for some things to work. So this installs, okay, now almost no one raised their hand for Node, for server-side JavaScript. How many people are writing CoffeeScript? I have, and I've got a hand. I've got actually a couple hands, which is great. I like coffee. I don't actually like coffee the drink. I like coffee the language. CoffeeScript as sort of syntactic sugar on top of JavaScript. It just compiles to JavaScript in a fairly straightforward way, but it does very nice things for your code. And so I recommend it if you haven't checked it out already. It's kind of a cross between Python syntax and Ruby syntax, kind of added to Node. So it's very appropriate for this talk, because it's all of them combined. Okay, did you guys notice this? How many people were really reading this code and noticed this line and thought, what the heck? That's making DNS work right for Node. And the reason that you need this is, I forget what the library is called. I'm not going to go into too much of this. But basically, Node uses a library that does actually have the capability on Windows of using the Windows mechanism for discovering DNS servers. But the way it's compiled into Node, it doesn't do that. And so it's always looking for the Unixy way of doing it, which is to look in resolve.conf. So when you pick up a Node distribution on Windows, you almost always find a resolve.conf in there that says like 8.8.8. It's got OpenDNS or something else set up in there. So it's got sort of a hard-coded DNS server. When you go to deploy that in Windows Azure, it fails because we do not route UDP traffic, which is what you need to do your DNS resolution. And so you can't make the call out to do the thing. You've got to use our DNS server. The network's all set up right. You never worry about this unless you're doing something like this. So you have to actually find those things. So after already showing off my batch file foo, let me show you some PowerShell I wrote. So that PowerShell script spits out the IP addresses of the DNS servers that are configured. So that line up there just runs this thing, sticks it all in resolve.conf, and then everything works. Is this boring? You don't actually want to know it, or is this we're geeky enough that we like it? I've gotten one thumbs up. No, is it because should I take the non-thumbs up as move a little faster? Okay. All right, I will make this a little bit briefer. So the Node version of this, it looks very similar to the other ones. It looks for app.js, but since I like CoffeeScript, I also look for one Coffee version of it. To get the dependency set up, I compile anything that looks like CoffeeScript, then I use npm to install any packages, then I call node app.js to run it. So see the pluggable, this is one of those places where you get to plug in your stuff if you want. Code syncing. All right, so let's talk about how we get the code onto the box. So you've basically now seen how we install Ruby, how we install Python, how we install Node, and you've seen briefly how we actually execute those, how we get the dependencies installed, so automatically bring in the right packages, and then how we actually execute the bits. The part that I haven't touched on is really how does the code get, remember when I edited some blobs and then things went wrong, but eventually things showed up on that web page. And so how does that syncing actually work? What happens? It's pretty simple. What happens is in a loop forever, it's actually a configurable option of what the interval is, but I think I've set it for every 5 seconds. Every 5 seconds, try to pull down new code from wherever that is, from blob storage or Git. Those are the two places I've done it. Run the install dependencies for everything. So just do npm install and bundle install and pip install, get whatever's there. And then launch the process with whatever we have. So basically, I have a little sync provider. I've shipped versions of that code previously on my blog. It's also, you saw the Umbraco solution accelerator that came out, the new version of that just came out. It's also doing blob syncing. That's how it keeps multiple websites up to date, and that's how it syncs sort of across instances for Umbraco to work. That's also based on very similar stuff. So I've done this a few times. It's basically code that just looks for new blobs or does a git pull, and if anything changed, then it fires up an event that says, hey, it's time to restart everything. And then what this code does is it'll tear down those processes that we started up. It'll start up new ones that are running the new code. I don't think I included the blob version of this, but this is the Git version. First of all, this is how we get Git on the machine. We unzip portable Git into the right place, and that's it. Here's more detail than you want, I can tell already, on the syncing. But basically, it does a clone, and then from then on, it does a pull. If it says already up to date, then it figures there's nothing more to do. Otherwise, it fires off this event that says we did something. Here's some long-winded code that just calls get.exe. That's it. That's actually the whole code. If you go take this and do new one-way git sync, give it a git URL, and then some local path, this will forever do a git pull in a loop, and it'll fire an event and whatever. I guess it's not a lot that it's doing. It's just calling git to do this every once in a while. The blob version of this code is not that different either. It does a list blobs, looks if anything is newer than what it has here, and then pulls things down if they are, deletes files that got deleted. It's a little harder because git pull does a lot of that work for you, but it's very similar. Okay, so did all of that make sense? Did I leave anything out? Is there a burning question about, well, wait, you didn't show us this piece of the puzzle? Because I didn't show you all the code, but I think I showed most of the key components. But is there something I just left out that's going to bug you before I move to other things? Okay. Coffee. It's all in CoffeeScript. So he asked if the chat app was in CoffeeScript or just JavaScript. And actually, yeah, all of it is in CoffeeScript, including a little storage library that I wrote for JavaScript for Node to use to talk to Windows Azure Storage. And storage is what I want to talk about on this slide. That's why I have this up here, which is basically when I talked about why are we doing this in Windows Azure, one of the benefits that I talked about was this scalable storage that we have, and that you might like that. You might get to make good use of that. We actually have quite nice capabilities in Windows Azure. You want to make sure that you can get those from these other languages too. And the good news is that the work is done for you in a lot of cases. I even recently learned there's a common Lisp storage client library to talk to Windows Azure Storage. There's an Erlang library. I've got links on the screen, which of course are hard to click on because you're there and they're up here, but you can find all of them on GitHub, actually. If you go look on GitHub, you'll find a Python library, you'll find a Ruby library, and you'll find code that I shipped this morning that is backing my chat application that only does tables and is somewhat limited in what it can do. But it can do it can put an object into tables and get an object and do delete. It does basic CRUD against tables. And I only worked on 2 out of these 3. So Win Azure Storage, the first one, the Python library, coworker of mine named Sriram Krishnan, whose book some of you probably have. He wrote the O'Reilly book about programming Windows Azure, and I think I saw someone carry it in, actually. So that book, he wrote a little Python storage library, and then I helped him add some new functionality to that. So we sort of worked on that together. Neither one of us participated at all in the creation of WAS storage, which is a Ruby gem that's actually been published properly, so you can just do gem install WAS storage. Works pretty well. Last time, when I built my blog, I used that, and I ran into a couple bugs, and I haven't submitted them back yet, but he's since made a bunch of fixes, and so I haven't checked yet to see if he already fixed the bugs I found. But other than that, it seemed fairly comprehensive compared to these other libraries. It was actually, compared to the libraries I was involved in, it was well written and well organized. And then, as I said, Node, I just sort of have this thing. SQL Azure, the good news is if you want to do a relational database thing, you want to talk to SQL Azure, all you need to do is find whatever the library is, whatever the driver is that does SQL for that language. And there's one in every language. SQL Server has been around for a long time. You don't need to look for, there's occasionally, things have come up where the library that does SQL Server doesn't like the connection, the string that comes back from SQL Azure that identifies the version because it's slightly different, so it's not in the list they already have. So a few of them have needed changes to do that. Some of those changes have already happened. I would just grab whatever your SQL driver is, the SQL Server driver, and then hit SQL Azure with it. Okay, so let's wrap this up with a little time for questions. Future work. So I don't think, now that the demos went the way that they did, I don't think I have to impress upon you that it is just a sample at this point. I think, let me separate sort of what it does and how it works from sort of where it is in terms of development, okay? And what it does and how it works, I think is fundamentally sound, makes sense on Windows Azure, makes good use of the platform, is something I would wholeheartedly support people doing in production. Now, how it's been built by me over the past week and with bugs in it and whatever, it's not at production quality, and so it's a sample, and so it's a starting point. But I do want to separate. I don't want to leave you with the impression that this sort of stuff is not okay to do on Windows Azure, or is not, or is going to lead you down some bad path. It is great to do this sort of thing. I encourage you to do it. I would like to help you do it. But the code that I'm shipping is a starting point. It's not a final destination. So things that we've got to add, some stuff about debugging and whatever. If you leave out some package that you need, then you get that 502 warning that I showed you, and you got to remote in and try to run it manually to see what's going on. So some sort of logging and stuff would be nice. Reliability, so the apps, so chat.smarks.com and blog.smarks.com, I think, well, those two. So my blog and that chat app are actually pulling from GitHub constantly. To see if anything's new. And so if I go do a git push to GitHub to change that code, it'll show up right away on my blog. It was just sort of scary every time you do a push. But now I've got this dependency, right? And even if I wasn't singing from GitHub, but I was singing from blob storage, like what happens if that fails at some point? VMs won't actually be able to start up in Windows Azure and whatever. And so it's a dependency that needs to sort of be worked through. What does that mean? This last one we already talked about, which is we really should use the update domains that Windows Azure has to help you to do rolling updates and make sure that you don't have downtime. That'll probably slow things down, or mean you can't deploy in a couple seconds. Instead, it might take a minute or so to get through it all. But you'd gain a lot in sort of robustness. Okay, so with that, questions? I also wanted to, this is my email address, by the way, so you'll find it, if you just go to smarks.com, you'll find all my contact info, so that's the easy way. I've just this morning published a bunch of stuff on GitHub, so if you go to github.com/smarks, you'll find the code for these various apps that we showed there. I thought we could pull up, yes, I wasn't satisfied with PowerPoint and built my own. I apologize. This is so to answer the question about was Node in JavaScript or CoffeeScript, this is the actual code for, oh right, yeah, it's on that timer. This is the actual code for chat.smarks.com. This is the whole thing, but you can go get it on GitHub. I lost it because, every 10 seconds it moves. It's kind of long. It's all in one big file. But check it out. All right, I'm going to stop fighting the timer. Okay, so we have 6 minutes and 30 seconds, according to the timer down there, for any questions you want to ask me about any of this stuff. It's better if you can get to a microphone and ask the question. If not, then I'll repeat it, and we'll still get it recorded. Okay, back there. Go for it. No, the question was, am I using WebSockets for the Node application? I'm not. It's long polling HTTP. So connection gets made from the client to the server, keeps it open for up to 30 seconds to wait for something to come, for new chat messages to come down, and then kills it and reopens another one. Or if it gets something faster than that, it reopens another one. So it's just sort of a long series of long polling connections. I could do WebSockets, except I learned in the keynote that the spec is always changing, and it'll cause me to swear a lot. So no, I just left it out because I wasn't really sure of where it was, or if I just didn't know a lot about it and didn't know if it would work in the browsers I wanted to use, like IE9. And so I just decided not to. But I don't see any reason why you couldn't, because we support TCP connections in Windows Azure, so you can open on whatever port you want and do that sort of thing. So I don't see any technical reason why it won't work. I just decided not. Yes.
Before I ask my question, I'll point out that there's an issue with ARR with WebSockets. So that would be,
okay.
Yeah, we won't support it at this current point in time. So that would be a blocking issue today on that.
Okay.
So my question is about the Node.js running on Windows. And are we talking about it just getting it running, or are we talking about getting it running and actually having it perform well?
I don't know. So, I mean, the question is, Node on Windows, is this just is this just it works, or is it actually something reasonable to do? Which is really, I mean, can it perform at the same level? I suspect it does not perform as well as it performs on Linux right now, because I don't think it uses I/O completion ports, which are the right way to do lots of open sockets on a Windows machine. And so I suspect that I haven't tested it. I assume that it does not scale as well as it does on Linux. That being said, I don't know how well it does scale, and I don't know if it's a bottleneck. It depends on the app and whatever. It seems to work fine for me chatting with, I've had a few dozen people in there, and it's polling storage all the time. And I've done some very impressive scale tests against storage, where I've been writing like 2,000 entities in a second and whatever, and it's done fantastically well with that stuff. But just the fact that it can't do efficient polling of the sockets, I think, means it can't hit the kind of massive concurrent connections that you'd see on Linux. That's just a guess. I really haven't tested any of it. But.
Do you have any idea of what the state is of like a native support for Node on Windows? So rather than running it on the emulation layer?
I've learned more from this audience about Node on Windows than I know. So yeah, I don't know.
Thanks.
Sure. Okay, go for it. Great. I love it. Okay, I'm going to repeat it because we want to make sure we get it on the video. So for people who watch this later, what I am being told is that Ryan and team are working on a proper Node on Windows sort of native support, which would use I/O completion ports, which means it should scream on Windows. That's the right way to do it. So good. That's fantastic news, because I really like Node. I think it's a really good idea. Having it be a first-class experience on Windows would be fantastic. So that's great. I like this talk because I've learned all sorts of things that have made me happy. So it's really good.
How many other people in Microsoft or teams or whatever are working on support for Ruby, Python, and Node in Azure, application server testing, compatibility, that sort of thing?
I don't think I know the answer to that question, which is, what is the rest of Microsoft doing with Node and with Ruby and Python? I know we just shipped some Visual Studio support for Python, which is not just IronPython, but also for CPython, which is cool. And there've sort of been scattered efforts that I've seen on these things. I don't know it's a large company, and so I don't know who else is doing what. I hear from people all the time. I do want to make sure that I leave people with the right impression about Microsoft employees' attitudes towards all this stuff, which is we all think it's very cool and we like it. It's not, you won't run around Microsoft and find a bunch of people who are like, stop doing that. No one told me not to do this talk because I'm evangelizing other platforms that aren't the .NET whatever thing. We actually, look, we want you to be running on Windows. We think that's important. We have a big business around that. We also want you to be running on Windows Azure, which runs Windows, so that's where we want you to be. We'd be happy to expand to as many of these things as we can. So I don't know what specific work happens, but I do want to make sure I let you know that, that's the spirit of this is we'd love to do more, and we'd like help. And so if anybody's interested in kind of in working with us on any of these things, you'd find lots of receptive people. Okay. Ori, you're flashing things at me. Are those the cards? Those are the... Okay, so Ori is reminding me that we have free Windows Azure for you people. And what, everyone's going to mob you. Is that the story? Wow. And the rubber band I'm watching it fly through the air, and they're just things sort of... And I'm like, did he just throw me a stack of things? Okay, so now you're going to mob me. But anyway, I've got all these things which... are cool. They basically just give you free access for a month to the Windows Azure platform, so come and get them. All right, so with that, I think we're out of time. Come up if you want to ask questions. I'm going to put like half of these here and half of these over here and trust you guys to do the right thing. Thank you.